So in the previous unit, we spent all on linear functions and how to write equations from information, how to write an equation from a visual, from a table, and then kind of vice versa. Then I would give them the equation and they would have to fill out the table and fill out the graph. And now I've actually given them a real life set of data, and it's supposed to show them that the world isn't perfectly linear, but we can use linear models to represent data and use that model to either predict future information, interpret whether this is a good model or bad model, interpret patterns. So that's how it fits in with the lesson. We worked on linear, and now we've applied it to real life data. So on the lesson prior to, we actually created a scatter plot, and that was the new vocab word for them. So I gave them a list of data, they made the scatter plot, and then we as a class drew in a line that we thought could best represent the data. And we picked 2 points in our data set, drew the line, we found the slope from the data. We worked on the y-intercept, and then we got our equation, and we talked about whether or not we thought that was a best fit model or not. We used our prediction line to find the residual values and talked about how the residual is the amount of error between actual data points and our prediction line. So we were focusing on what the residual meant and how that could be helpful to decide if our model is good or not. Then their homework was to sum all the residual values from our prediction line to each data point. And then that's how we started this lesson, talking about that the sum of the residuals is 5.3 and talking about what does that mean? Is that the only model that we could have created to represent the data? And they quickly understood that that answer is no. And then we talked about how now we're going to use our calculator to actually find the best linear model. And then as we went through that, we found the sum of the residuals to be close to 0 because of rounding errors, but that has the lowest amount of total error, which is why that is the best linear model, and just discussing that. And then the next day, we're going to interpret information from our actual model, like what does the slope mean for this real situation? What does the y-intercept mean? How can we use this data? Can we use it for somebody who's 25? Can we use it for somebody who's 35? And talking about how not all equations work for all data for one situation, because when you get to be, 18, your feet probably stop growing, so we can't use that linear model anymore. And then I'm going to give them a new set of data where they actually have to do it all over again, but all on their own, so that they make sure that they understand how to find it and why this is useful. This is the piece that got lost. Stats, I think a lot of teachers felt like there's so much to teach in algebra that the stats piece was getting lost. And we think that they do that in science. They work with graphs, they model data, which they do, but they also need to see it and hear. And that's the real world. When people collect data, they collect it for a purpose, and then they have to interpret that data. And that's something that we need to work on here and give them those skills, not just teaching them, hey, this is y equals mx plus b, where this is the slope, this is the y-intercept. You plot the y-intercept, you go up 1, right 1, up 1, right 1. I call that making robots. We're just telling them what to do without any knowledge of why they're doing it or how it can be applied. Now, with Common Core, they're bringing all those important pieces back and focusing on the understanding, the justifying, the explaining, and how we can use the math in the real world to make the world better and to make themselves better. Having them work in pairs where one person was working with the calculator and the other person could be watching the model calculator on the front of the board, I think that interaction is really important. I remember being a student and sometimes feeling lost, but if you have a point person to talk to, that's not only engaging, but that's also helping each other learn. You not only learn from listening, but you learn from explaining. So one person is listening, one person is explaining, and then it switches off based on who has the questions. It is also easy for me to walk around and hear their conversations, hear their questions, and what I like to do a lot is tell one person within a group how to do something, and then they have to repeat what I said to the other groups or other group members. So one person is getting that one-on-one for me, I'm checking in, and then I can listen to them explain it to other people. So that person is really getting both pieces, the listening and the explaining part, and so I'll make sure to go to different people and switch off who I'm giving that role. From some of the submitted work was their post-its and explaining whether they thought those scatter plots could be represented by a linear model or not. And what delighted or surprised me was that I see that they are talking about patterns, and they were noticing that 1 and 4 have a constant rate of change pattern, which they know applies to a linear situation. So that that makes me happy that they understand what a rate of change is and how that applies to a linear situation. And then they also noticed that 3 and 2 could not be represented by a linear function because there was no constant rate of change. They saw that the data was increasing and then decreasing, which isn't linear. And then they also saw that there was no correlation between data set 3 because there's no pattern to the data. So that made me happy. I was surprised at how well they were doing with the calculators. I thought that was going to be more of a challenge than it was, but they picked up pretty well. I would like to see I would have them interpret the slope and the y-intercept first before moving on, and then I actually wanted them to calculate the residual values. We ran out of time for that, which is why I showed the answers and we found the sum together. But having them practice the actual residuals, that would have had it made more sense to them as to why the actual sum was 0. And that's something that I will do the next day. Things always change and we run out of time because we have good conversations, so it's always modifying the next day. And working on something that we did the prior day that they didn't get, or weaving the good comments that they make into the next lesson. So tomorrow will be different than I thought it would, but I'm happy that they saw the patterns between linear and nonlinear, and that I feel that they understand the point of a residual more than they did in prior lesson.